So on number 5, you'll notice that I had to change the problem a little bit. So when I do this, I have to square both sides. So when I do that, squared and squared cancels out, like square and square root cancels out. And remember here, when you're doing x minus 1 squared, you're really doing x minus 1 times x minus 1. That gives you x squared minus 2x plus 1. I need to get a right side equal to 0 in a quadratic, so I do minus 2x plus 3. Factor that out. What adds to the middle multiplies at the end. That's minus 2 and minus 2. So this gives me x equals 2. Parentheses are liars. Set them equal x minus 2 equal to 0 and solve. And remember, I have a square root here, so I need to plug into my original equation. Let's check that carefully. So when I plug in x equals 2 where x is, that gives me square root of 2 times 2 minus 3 equals 2 minus 1. If I type this in my calculator, that'll give me 1 equals 1. So this is a solution. 6, I've got to do a sign chart. And notice here on the sign chart, it wants negative. So it wants negative or 0. Because it wants less than or equal to 0. So it wants it to be less than or equal to 0. So I'm looking for negative or 0. So remember with the sign chart, I set up my sign chart. This gives me x equals 2. I set it equal to 0 and solve. And then here, the denominator can't be equal to 0. So I say x can't equal negative 1. So if I put that into a sign chart here, so does not equal, that's not 1, that's a D right here, does not equal, and then 0. And I plug in values before, between, and after. So a number before this is negative 2, a number here is 0, and a number here is 3. So if I plug this into my original expression, you'll see that I actually did this already, but I forgot to turn on my mic when I recorded this. So it's me re-recording it. But anyways, if I plug in negative 2 into x right here, I get this right here. So if I plug it in, I get 4. So I'm looking to see if it's positive or negative. It's positive. And then for 0, when I plug it in, I get negative. And for this right here, I get, what was it again? Yep, it's positive. Okay. So remember, we only want negative or 0. That happens between these two guys right here. It happens between 1 and 2 in that interval. So the way I write that out is parentheses negative 1, because we can't include it. It does not equal negative 1. We can't do that because it gives me 0 in the denominator, and then 2 with a bracket. So that would be my final answer here. Now, if it said greater than or equal to, what my answer would be is up here in blue. Now, notice, this is if I change this sign right here to greater than or equal to. My answer would be negative infinity to negative 1, parenthesis once again, does not equal, union to infinity. And if you were paying attention, you'll notice that I made a small mistake here. There should be a bracket because it would be greater than or equal to in this case. Number 7 is pretty tricky, so make sure you pay good attention. A boat travels 60 miles upstream. Sorry about that. I'll try to open a tab. So when we're working on one like this, we should see that it says there's 60 miles upstream and 60 miles downstream. The current is 3 miles per hour. The trip took 5 hours in total. And what's the boat speed in still water? So, one thing I need to note here is that upstream is against the current. So upstream means you're going against the current, and downstream means you're going with the current, so it's helping you. Against current, oh my gosh, and with current. If the current is 3 miles per hour, what we're looking for is the boat speed in still water. There's no current at all. So let's say B is the boat's speed in still water. Okay, we'll say that B squared, or not B squared, but B plus 3 then would be the boat's speed. B plus 3 is the boat speed downstream. And B minus 3 is the speed upstream. Where I'm getting this from is the speed upstream means that I'm fighting against the current. So the 3 miles an hour here is like pushing back against my boat. Whereas if I'm going downstream right here, where it talks about going downstream, like if I'm going, the boat is being pushed downstream with me. Like it's adding 3 miles an hour to me. It's like the wind's behind me, except for it's water. The water's behind me pushing me. So downstream and upstream. And really, like they're gonna give you one that has the same speed both ways. So as long as you set it up, it doesn't really matter that you completely understand. If you could say plus 3 and minus 3, it goes with one of them, cool. Now, if you go 60 miles upstream and 60 miles downstream. Because remember, what is this here? Like speed is in miles per hour. Speed is in miles per hour. So if I have miles per hour and I want time, and I want speed, I end up needing use this right here. So time is equal to distance divided by speed, right? Like if I was finding time, it's going to be my distance over my speed. So this is a key thing. So I spent 5 hours total, okay? And to have a thing in terms of time, I'm gonna plug in the distance and speed both ways. So the 60 miles upstream, so 60, that's my distance, over my speed upstream. My speed upstream was B minus 3, 60 over B minus 3, plus my 60 miles downstream, that's my distance over my speed, and my speed was B plus 3, okay? So now I have this set up here, and I can multiply by the least common denominator, which is just going to be these two combined, B minus 3 and B plus 3. So I'm going to multiply the whole thing by B minus 3, B plus 3, B plus 3, B minus 3, B plus 3, B minus 3, okay? Multiplying every term by that. Because here, the minus B minus 3's cancel out, and I'm going to multiply 60 by both of these, so that gives me 180 plus, or I should do this one first, sorry, 60B plus 180. And then the plus 3's cancel out, distribute the 60. That gives me plus 60B minus 180 equals, let me extend my page right, Over here, I've got 5 times b plus 3 and b minus 3. Let's do that over here. So 5 times b plus 3 and b minus 3. If I distribute this out, you'll end up seeing that these two multiply to b squared minus 9. So if I distribute this guy here, that gives me 5b squared minus 45. 5b squared minus 45. Okay, so here the 180s are going to add out, and I have 120b equals 5b squared minus 45. I need to minus 120b to both sides to get it equal to 0. That'll give me 0 equals 5b squared minus 120 minus 45. Oh, 120b. Now, here, there's nothing that's going to add to negative 120 and multiply to negative 45. So I'm going to have to use the quadratic formula here, where a is 5. So let's write that out. A is 5, B is negative 120, and C is negative 45. So if I go over to my calculator here, gosh, dude, why? This thing does not want to work. So here, if I look at this guy, there we go. My computer's not wanting to work with me. So if I use the quadratic formula, that's going to be negative b, so it's going to be negative 120, so 120 plus the square root of b squared, so negative 120 squared minus 4 times 5, my a and my c, all over 2 times a. Okay, that is one, but it's plus or minus, so I'm going to change this to a minus. So we've got b is either 24.369 blah 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 or some negative number. Remember, b is the boat speed in still water, so negative speed doesn't make sense. So I would say the boat speed b is about 24. It'll tell you what to round to on the test. We'll do 2 decimal places for now. 24.37 miles per hour. 7 is done. Now let's move on to 8. You invested $5,000 into 2 accounts earning 4% interest and 6% interest. If your total interest after 1 year was $260, how much was invested into each account? So for this, the way we set this up is we'll say we have $5,000 total, okay? So we'll say that X is the amount that went into 4%. Okay, so if there's X in that one, and I've got 5,000 total, then 5,000 minus X is going to go into the 6%. I can't type. 6% investment. Okay. My goodness, I'm struggling. So 5,000 minus X is going into the 6% investment. So if I look at this feller then, so this is my interest. X is the amount of interest from the 4% investment. 5,000 minus X is the 6% investment. So if I set it up like this, so 0.04 X, okay, because that's going to be the amount invested, and multiplying it by 0.04 is going to give me the interest, and 1
had 0.06 or 6%, and that's going to multiply by the amount that was in there, so 5,000 minus x. Okay. And the total interest was 260, so that equals 260. So I distribute .06 times 5,000. Check my math here. My brain's not working. There we go. So 300 minus 0.06x equals 260. And then if I combine like terms, I get 300 minus 0.02x equals 260 minus 300 on both sides, and that gives me 40 on the other side, negative 40 I should say. And if I divide by negative 0.02, so negative 40 divided by negative 0.02, that gives me x is $2,000. Okay, so 2,000 would go here. So 2,000 went into the 4% investment. If there was $5,000 total, that means that there's $3,000 to go into the 6% investment. The width of a rectangle is 4 meters less than its length. So if I draw my rectangle here, the width is 4 meters less than its length. So if I write that out, the width is the length minus 4, right? The length minus 4. Because the width is, so W equals 4 less than the length. So L minus 4, and this is L up top. If the area is 96 square meters, find the dimensions. So I can multiply these two together, length times width. So this is my width here, length times width. But if I have these both in terms of L, that gives me a nice equation. Because area equals length times width. So 96 equals L times L minus 4. And that gives me 96 equals L squared minus 4L. And if I minus that over, I get 0 equals, or subtract that over I should say, L squared minus 4L minus 96. And here, this factors out to L minus 12 and L plus 8, because it adds to negative 4, multiplies to 96. I did have to pause the video to check that one for a second because I was struggling to break that apart too. But this gives me L equals 12 and L equals negative 8. So one thing I'll say here is where L is the length, right? So it doesn't make sense to have negative 8 meters for a length. 12 does, so we'll use that. So we'll say this is 12. And if this is 12 minus 4, then this has to be 8. So the length is 12, the width is 8. Now we move on to finding the domain of this function over here. And really when you're doing these, usually what's the domain of a function, right? The domain is usually negative infinity to positive infinity. So the usual domain without anything screwed up. Well, what screws up domains? Variables in the denominator and variables in a square root. So right here, we basically just have to check and see, okay, right here, what can't this be? First, let's factor that. That factors to x plus 3 and x minus 3. And we know that that can't equal 0. So x can't equal negative 3, because parentheses are liars. Let me write that again. That was a little bad. Negative 3, and x can't equal 3, right, from these two right here. So basically, everything in the domain, negative infinity to positive infinity, works except for negative 3 and 3. So if you remember, the domain here would be, I start at negative infinity, then the first hiccup I run into is negative 3. So to skip over it, I'm going to put it on both sides in a parenthesis. So negative 3, parenthesis, union, negative 3. The next hiccup happens at 3. union to infinity. So that's my domain. So the domain here, what is different about this? I said this one is another one that screws it up. Why? Because there's a square root with a variable inside of it. So for square roots, the inside of a square root must be greater than or equal to, here, let me write that with a pen, must be greater than or equal to 0, right? Because I can take the square root of 0, square root of 0 is 0, but in the real numbers, I can't do the square root of -1. I can't do the square root of negative numbers, right? So this greater than or equal to 0 is coming from the fact that I don't want to work with negatives in the domain of square roots. So here's what this would look like. So I take this right here, x plus 7, so what's inside of the square root, and I say that it must be greater than or equal to 0. Well, if I'm minus 7 on both sides, I'll isolate my x. Because remember, domain is working with my x values. So x has to be greater than or equal to -7. So here, this is technically an answer, but usually you'll write it in interval notation. So I think it is like an arrow pointing this way. So it's pointing to the right, so I'm going to start at -7. So bracket -7, comma, infinity. Then it asks us to find the slope and y-intercept. So this is just telling me to get it into y equals mx plus b form. If I do that, I go to minus 2x on both sides, minus 2x. So let me bring this result over here. So that gives me 3y equals -2x plus 9. And divide by 3 throughout. Divide by 3, divide by 3, divide by 3. So y equals -2/3 x plus 3. So here the slope is in front of the x, so my slope is -2/3, and my y-intercept is that number at the end. My y-intercept is 3. Number 13, you can use point slope form. Write the equation of a line through 2, 5 with a slope of -3. So remember, point slope form, we're working on number 13, but we're working in the 12th space. I would be working on another sheet of paper. So y minus y1 equals m times x minus x1. Okay, so this is, when I do this, remember this is x1, this is y1, and this is my m, my slope. Okay, and then I'm going to get y by itself. So when I plug this in, I have y minus 5 equals, my m is -3, x minus 2. So if I distribute then add 5 to both sides, I get y equals -3x plus 11. So the equation of the line is this guy right here. Okay, and that's the y equals mx plus b, the slope-intercept form. So if it asks you on the test, remember this is your point slope form. Okay, and this guy down here is my slope-intercept form. You'll start with the point slope form and then solve it down to slope-intercept. Number 14, it wants us to find f of g of x. So this means, the way this is written means substitute g into f. Like you go this one into this one. So the way I remember to do it is I build a skeleton and put parentheses wherever there is an x. So right here, I'm going to put a parenthesis, and right here I'm going to put a parenthesis. So when I write that out, so f of g of x, okay? I'm going to start by writing f with just parentheses, so parentheses squared plus 2 parentheses. Okay? And what am I plugging in where the parentheses are? X minus 1. I'm plugging what g is into those parentheses. So I have x minus 1 here. X minus 1, x minus 1. We did this earlier. X minus 1 squared, remember, means to do x minus 1 times x minus 1. So it gives me x squared minus 2x plus 1. And that's just from this part. And then this part over here, if I distribute the 2, gives me 2x minus 2. If I combine like terms, that should give me x squared minus, oh, no, minus, because these are going to cancel out. And I just have minus 1. So f of g of x is equal to x squared minus 1. Last one on this video, we need to find the inverse. So remember to do this, the way you do it is you write it as y equals instead of f of x equals. So, okay. And then you switch x and y. And then we isolate y. So add 5, add 5. So x plus 5 equals 2y. Then if I divide by 2 on both sides, I'll have x plus 5 over 2 equals y. And then remember, the final step is when I have y by itself, I write it as f to the negative 1 of x. And that's just the notation for inverse. So x plus 5 over 2 is the inverse